So now that we know about unions, we can talk about intersections. And so the intersection of the sets A1, A2, up through AN for n greater than or equal to 2 is denoted as, you can either write A1 intersect A2 intersect AN, or you could also write this as I equals 1 to n AI, and is defined by the intersection here. It's the collection of elements, so X, where X has to be in AI. It's for every I. One less than or equal to I, less than or equal to n. So remember, when you're taking an intersection, you're asking what elements do they have in common. And so if you have an element in the intersection, it has to belong to every set in that intersection. So let's look at an example where we're computing these intersections. So let's say the set BI, let's go with our previous example. It's I and I plus 1 for I from 1 up through 10. And I want us to determine the following. So the first one will be the intersection from I equals 1 to 10 of BI. So let's write it out. It's B1, which would be 1, 2, intersected with 2, 3. It's B2, intersected with B3. And then you keep going until you intersect with 10 and 11. So look at all these sets. Do they have a single element in common? Is there one element that belongs to every single set? And the answer is no. So this intersection is the empty set here. Okay, so maybe we took the intersection of too many sets. So maybe let's just look at BI intersect BI plus 1. What would this intersection be? So if you want to, again, you can pause the video right here and see if you can figure out what the intersection would be. But let's go ahead and do it. So I'm intersecting the set I and I plus 1 with the set I plus 1, I plus 2. And then what do these two sets have in common? It's just I plus 1. And we're going to look at one more intersection problem for this example. Let's intersect from I equals j to k of BI, where j is less than k. So here, when I intersected, in the previous example, when I intersected two consecutive subscripts together, I had an intersection. So we know that if k is one more than j, then this intersection, we calculated it in the previous problem, it's j plus 1. And then if K is strictly bigger than J plus 1, then this intersection you'll be intersecting more than just 2 sets. You'll have 3 sets. And then there won't be any common elements between those 3 sets. So the intersection here would be the empty set. Okay. So there's my intersection.